Hey everyone, welcome to The Explainer. Every single time you stream a show or jump on a quick video call, there is this massive, totally invisible infrastructure that instantly goes to work. Today, we're pulling back the curtain on what I like to call the data highway. We're going to explore this absolutely monumental shift to IP networking, the hidden system that quietly powers pretty much our entire modern digital lives. Let's get right into it. Okay, let's dive into this. At its core, what are we actually building when we put together a data network? Think about the fundamental problem of telecom. We literally have to connect billions of completely isolated devices scattered all over the planet. It's wild. The network is basically the living, breathing solution to that massive logistical challenge. To make it simple, think of this infrastructure like a vast system of physical roads. Just like roads connect our houses, a data network connects your laptops, your smartphones, smart TVs, even that local printer in your office. We aren't just connecting two simple endpoints anymore, right? We're managing traffic for billions of devices simultaneously so they can all seamlessly interface and share information. Now, to actually make these connections happen in the real world, we rely on two main physical pathways. First up, we've got wired connections. Think incredibly fast, light-based fiber optics, or copper Ethernet. These provide the massive, high-capacity backhaul for all the heavy lifting. On the flip side, we have wireless connections. These use radio waves flying through the air, like your Wi-Fi or mobile data. This gives us that essential edge mobility, so we can actually stay connected on the move. And honestly, both are absolutely crucial to bridge the gap.
So, how does the data actually travel? It happens in three super fast stages. First, a sender, like your smartphone, packages up a message. Then it gets thrown into the chaotic, complex middle ground we call the network cloud. Finally, it's delivered to a receiver, like a server. As professionals in telecom, that messy network cloud, that's our territory. That's where we operate. Our whole goal is just managing that complex middle ground so your data transfers quickly, safely, and accurately, letting you enjoy your social media and video streaming without a hitch.
So, is a network simply just a bunch of cables and antennas? Actually, scratch that. It's way more than that. It's a complete living system. Whether you're an engineer or a field technician, you gotta remember that telecom isn't just about plugging in physical cables. You're working with a vast, dynamically interconnected ecosystem to get digital information successfully from point A to point B.
Section 1, the big shift from voice to data. And this brilliantly illustrates the massive evolution we've seen in the industry. Back in the 1990s and earlier, networks were strictly single-use. They were built only for basic voice phone calls. If you wanted data, you had to build an entirely separate, clunky parallel network. But then, in the 2010s, we hit the big shift. Everything transitioned to data. Fast forward to the 2020s, and modern companies like STC, Vodafone, or Etisalat, they're no longer just traditional telephone providers. They operate as full-scale internet, streaming, and cloud service providers. So, what was the bridge between those eras? It's the Internet Protocol, or IP for short. IP is literally the universal language that makes this entire modern telecom and data world possible. It acts like the foundational traffic law for our digital highways. By adopting IP, the industry finally found a standardized way to package, route, and deliver every single type of digital information across the globe. Section 2, why IP rules everything. We're going to look at the rule of 4 here. To really understand why IP completely replaced those old, clunky, parallel networks, we just need to look at 4 critical metrics: convergence, cost, scalability, and compatibility. These 4 pillars show a totally stark contrast between the old legacy architecture and the sleek modern systems we rely on today. Now, what's really interesting to look at here is the first point, convergence. That old, inefficient reality of building separate physical networks for voice, TV, and internet, totally gone. IP allows a single, unified pipe to carry your phone calls, high-definition TV, and internet at the exact same time. It's elegantly folding parallel universes into one streamlined system. Second up is cost efficiency. Let me tell you, maintaining millions of decaying traditional copper lines was an absolute operational and financial nightmare for telecom operators. By transitioning to a unified IP network, providers drastically lowered their costs. Building and running one IP network is just vastly cheaper and faster than dealing with all that old copper. Then we have number 3, scalability. How do you handle literally exploding global data demands? You definitely can't be out there digging up the streets to lay new, specialized cables every single day.
Because IP routes data digitally, telecom companies can easily scale up. They can add millions of new customers and push major software upgrades to increase speeds, all without physically rebuilding the core infrastructure every time.
And the fourth reason is absolute compatibility. Take a second to just look at the devices around you right now. Your smartphone, your laptop, smart TVs, even CCTV cameras. They all inherently speak IP. Because every modern device you touch speaks this universal language, the core telecom networks absolutely must use it to communicate with them effectively. Honestly, without IP networking, we are essentially sent back to the technological dark ages. Just imagine it. No high-speed home internet, no mobile 4G or 5G data to browse on the go, no cloud computing, and absolutely zero YouTube or Netflix streaming. None of it. You just have basic voice calls over landlines. IP isn't just some convenient technical upgrade. It is a fundamental necessity for modern life. Period. Section 3, the Mechanic's Mandate. This brings us to a really crucial point. You are the mechanic of the data highway. If you're working in this field, you aren't just driving around fixing wires or resetting routers. No way. You are the essential guardian keeping the entire modern digital world up and running. Maintaining this infrastructure means you are maintaining the literal lifeblood of global communication, commerce, and everyday life. Think about this for a second. If the IP network fails, all modern telecom services stop completely. But what stops with it? Well, if the data highway crumbles, so do our financial markets, our hospitals, our emergency services, and our connection to the people we care about. The stakes literally couldn't be higher. So, what does that mean for the future of our networks? We'll leave that thought right there for now. Thanks for tuning in to this explainer. Keep digging into the network, and I'll catch you next time.